Alright, time for another DraftPhysics.com video presentation. Debate physics also. Now, this vt.physics, I believe I did email, attempting to provoke some interest in the kinetic energy subject. And it's kind of awkward in the sense that it, she makes a lot of these shorts, okay, which are, sort of junk videos in my opinion. And the content is so, it's the generic school, probably more kind of grammar school type content. But there is something, it's just the kind of thing where you can't not notice. If somebody had 4 eyes or 2 noses or some sort of thing, you'd have to, like 2 heads, you'd sort of have to, see it. And the strange thing is she obviously looks like, a 14-year-old girl, maybe a 14-year-old boy. And so it does put somebody in this weird position where you could say, if somebody said she was romantically interesting, would that automatically make them a pedophile? It's a kind of entrapment, but you can't really say, oh, she's cute. Well, maybe, no, not really. And she plays the part. Okay, so yeah, she's doing the tomboy thing. I don't know why they don't call them tom girls, but whatever. And so maybe if she's in the right costume, it gets easier to recognize that it's a woman. It's not a girl even. She's an adult. But anyway, so I'm just saying it because I'd be kind of lying if I didn't say I'm distracted by the fact that I can't really see past the fact that it seems like a kid, okay? And then what are the implications of that in terms of the appropriate interaction? All right. So anyway. But she's not, anyway. So just throwing that in there, very strange. All right, so the subject is this simple, this shouldn't even be a conversation, frankly. Come on. And the fact that you have to go over this stuff too, like you have to point it out more than once. So this came up with the Mythbusters thing. So the Mythbusters did a video where they crash cars. And so they didn't find any evidence of the kinetic energy theory in the car crashes. But the whole point was they were sort of arguing that 2 cars going 50 miles an hour doesn't equal 1 car going 100 miles an hour. And it does. It's just wrong to say it doesn't equal it. It's just not... it's not honest, okay? The fact is that the collision is 2 50-mile-an-hour combinations of momentum. You're not subtracting the momentums. You are adding the momentums. And you do have an impact, okay, that's going to equal, twice the momentum of the 50-mile-an-hour into a brick wall. And that twice the momentum, you could clearly easily measure it if you just move your spring, okay, from using 2 springs essentially to measure the explosion to just 1 spring and measure the explosion, and you'll see that it's obviously twice the impact force. Now the car driver doesn't see the difference, but the thing in between the car drivers would see it. So it's this simple, very simple. Gotta get rid of this. All right. Scenario. So the Mythbusters did it with hunks of clay and weights and smashing things together. And essentially what they did is they put a weight behind a spring, you could argue, and a weight behind a spring, and so they combined 2 springs. And so half the force went into this spring and half the force went into this spring. But obviously if you change the scenario just slightly, okay, and don't have any springs, just have your weight and a weight over here with no spring, okay, and you crash them into a spring, okay, just one spring, you're going to get twice the compression of the spring. So you're going to measure twice the energy for the impact. All right. So it's just wrong for them to imply that because from this thing's perspective, there's no difference. Okay, this thing's going to go from being 50 miles an hour to 0. Okay, it's going to stop. And that doesn't matter whether there's a brick wall or this guy over here. It's the same difference. But it's obviously not the same difference if you were standing here in the middle. So if you were standing between the two cars, you can obviously understand it's going to be just like getting hit by a 100-mile-an-hour crash. This will equal, you know, a 100. So 250s, okay, will equal a 100 if I use a brick wall. So if 100 miles an hour with a brick wall will equal 250s crashing into each other, or 250s crashing into a brick wall. You know, no doubt about it. And so it's just wrong to imply that there's not a distinct difference between the energy of this one event and combining both events. But because their math has this minus sign in it, you know, they have this idea that somehow there's zero momentum, you know, that you haven't changed the amount of momentum, when clearly you have changed the amount of momentum. It's 50 plus 50 hitting the middle. Alright, so I'm just making that clarification that I think it's very deceptive. I just don't think it's not accurate to give the impression that there's no difference in what physically happened between a 50 mile an hour into a brick wall and then two 50 mile an hours into each other. That's a different event. I think I've clarified that. Good enough. So it's a short video, so we should be out of here pretty quickly.
Exactly the same. Two identical cars traveling at 50 miles per hour collide head-on.
Right, so these videos of the car crashes really do illustrate the point, okay? The fact is you could increase this to 75 and then increase it to 100 miles an hour, and what you'll see in the crushing of the cars is a very consistent confirmation that momentum is in control. And there won't be any evidence that kinetic energy exists, in the sense that there won't be any sign of an mv squared amount of energy being created.
And come to an immediate stop. And here's the car colliding with a concrete wall at 50 miles per hour. Is crashing two cars together at 50 miles per hour the same as smashing a car into a wall at 50 miles per hour?
It obviously isn't for the wall. So, you know, so again, if you measure with two springs, the impact is going to be split between the two springs. But obviously, if you measure it with one spring, that is, you're going to measure the total amount with one measuring mechanism. Clearly, one spring in between the two cars is going to measure 100 pounds, 100 times 100 worth of compression versus just 50. It's not going to measure 50 or 50. It's going to measure 100.
If you know the answer straight away, comment below. If not, stay for my mathematical proof.
So again, she's going to claim that somehow she's proving, right, that 250s equals 50. When no, 250s does equal 100.
The car's change in momentum is calculated by the car's mass times the change in velocity, or it's the final velocity minus the initial velocity.
And so again, that's your way of interpreting it, and that'd be fine if you're not in a circumstance where you have more than one thing's contributing energy. So if you just had one object and only one object to worry about, that would be fine. But you're not. You're combining multiple objects and doing the vector math.
Because the cars in both situations were brought to a stop from 50 miles per hour, the change in momentum is just the car's mass times 50 miles per hour. And we know that change...
Yeah, but we know that those two zeros are not the right answer, okay? To say there's zero momentum would be ludicrous, because obviously a ton of momentum bent both cars. And it's just the fact that if you put the car in the middle, and you put the cars that crash in being very indestructible, then that car in the middle is going to be crushed twice as much as either one of the two 50-mile-an-hour cars would have been. So it's just a fact.
Momentum is proportional to the impact force by this equation. So this shows that the impact force is the same for both situations.
So we know the impact force, that is the total momentum, is much higher in the case of the two crashing into each other. The total momentum of this, okay, 50 miles an hour into the wall, the total momentum of this is twice the total momentum. It's twice the explosion, and it does twice the damage. It obviously crumples two cars. It doesn't crumple one car, it crumples two cars. It's obviously twice the energy.
Yes.
Okay, so kind of, again, it's just this, I don't know what you call this, lazy physics or, you know, superficial physics. It just doesn't really, it's just not getting to the substance of what energy is. And again, it's really founded on this idea that I'm going to turn everything into a zero equation and pretend that there's such a thing as minus energy in the universe somewhere, that somehow I can create a negative energy, and therefore I can subtract it from some sort of positive energy and get no energy. And I would argue there's no such thing as negative energy. There's not negative motion. These things don't happen. They don't exist. And anytime two vectors collide, they can't collide unless they are going in opposite directions. You add their force, you don't subtract it. Okay, so enough of the video, quickie. But it'd be nice to be able to get a physicist involved in this kinetic energy argument, but it just doesn't seem it's possible. And again, this one might be a little too light and fluffy for the kind of darkness that the argument requires. The fact that the argument's a bit rude and unpleasant probably will discourage her participation, unfortunately. So till the next time, and such and so forth and whatnot.